Hi, my name is Vrinda. I'm a senior software engineer at Block, and I build infrastructure for hosting and serving machine learning models. I've been a software engineer for around 9 years.
Hi, I'm Sujata Sridharan. I'm a senior engineer at Bolt. I work on applied AI in fintech and e-commerce domains majority of the time. I've been a software engineer for about a decade as well.
We have been working with AI for few odd years now. LLMs have come in and we have experimented a lot. But getting from prototype to production isn't as seamless as we thought it would be. So we have been so used to with our traditional software design as they worked in a deterministic world. So jumping into this non-deterministic, this probabilistic world isn't as smooth as a transition as we had hoped. I wanted to take a mental model or create a mental framework to map our traditional software practices and how we can evolve into this AI native world. So that's the inspiration.
As someone who works with applied AI, I think that engineering and SDLC in general had evolved to a point where things were templatized. There were very fixed patterns. So even though you were working on niche domains, you still had a very shared vocabulary with which you could approach them, and you had solutions that you knew had worked. But now AI is here and it's completely flipped our game. So like you said, dealing with probabilistic model in its core, we still are trying to figure out what our shared vocabulary should be and how should our patterns look like for these new systems. So we're kind of at that critical point where as adoption starts to scale, we need to have these conversations so that just like event-driven systems or batch workflows, we have a similar set of vocabulary for AI native systems as well that we're able to build effectively with.
Yeah, so just as you say, what is prompt engineering? I should know what all patterns to apply or what
just
it really
means.
Just
common sense, right? We should be able to have engineering conversations, have system design discussions, and be able to just roll from there because we all are talking about the same thing and we understand what we're talking about.
Exactly.
Yeah.
Makes sense.
Yeah. To me, an AI native design pattern is when you're building structure around these probabilistic system in its core. So it can mean different things depending on the level, but I think that is in crux what we're trying to do. We're just trying to wrap it up in this huge engineering bubble, similar to all the other patterns that we have, and just trying to get to a point where we get deterministic output, even if the systems themselves are non-deterministic.
We are not here to make LLMs non-deterministic. They will stay the same. So what we can do, I think, on our part is make our systems wrap them in enough structure so that even though the output we get is non-deterministic, there is some determinism to our output and there's some determinism in the actions that our application is taking, and even if it is unpredictable, at least we have enough safeguards. So nothing wrong is shown to the users at the end of the day.
Absolutely. And the side effect of something like this, I think we kind of touched upon this in the talk as well, is that just by attaching structure and some of the patterns that we've spoken about, we also kind of start to deal with more structured output, which means we get more predictability and reliability in production overall. So I think that's really our overall goal by calling these AI native design patterns. We're not trying to reinvent the wheel. We're just trying to bring some kind of shared vocabulary so that we're all able to try to build in this new AI driven world.
You have your inputs and you add lots of test cases around it in your traditional software. So you kind of assume that if the input is right, you'll get the correct output because you have added all these tests, your integration test, your canary test, and so on. So you assume, okay, if something's going wrong, it's possibly a network issue or something, and you'll retry, you'll add retries, and if the input is right, you'll get the right output. But that doesn't seem to happen with an AI system, right? So even if your input is coherently right, you think it's right, but LLMs might decide I'm not giving the correct answer today. So so just simply retrying here will not do you any good. So unless you have a good prompt with good retriever and good context wrapped into it, it will just not give you the answer you were hoping for, even if the input is correct.
Yeah, I have a slightly more human answer to it. I think the other thing that people don't realize, especially if they're not familiar with these AI systems, systems is they sound human. It feels like I'm talking to a human on the other side, but they're not actually human, right? They're just like really large-scale reasoning models. That this as a user, when I'm working with these systems, I'm trying to like still talk to them as human. I'm still depending on them to pick up like contextual cues and like, you know, body language and things like that, but they can't. Just because they sound human doesn't mean they are, which means we really need to like thinking and approaching from that frame of mind and start like building like the right guardrails, right structure, right stability and right context so that they're able to do their job effectively. So I think like that's like a slightly different take, but people don't typically talk about that as much.
Yeah, no matter how many feelings the LLM shows it has, it really doesn't understand those.
It's just trained to do so. Yeah.
That's great.
So prompts are really our first point of interaction with these systems, right? They are like the top level of like any AI-driven system. So in order to actually influence the behavior and bring structure, we need to bring structure to prompts first. We spoke about a few techniques in general, like things like just having like structured prompting, like having like role plays, in like wrapping them in like JSON schema, and also things like end-shot prompting, trying to provide a mini training data set of sorts like at inference time so that you're able to constrain and like direct the behavior in the format that you want. I really think like all of these work holistically, but also you do need to start at prompt level, and sometimes that gets ignored because people think that prompt engineering is not like a core engineering problem, but it absolutely is because it is your interface.
Oh yeah, definitely. And I think there's so much research going into this, and I remember a time where I put everything in my prompt and I said, okay, give a JSON, validate the answer and everything. So the flip side of it is prompts cannot do everything as well. And now I've seen like increasingly the APIs themselves, the LLM APIs themselves have this structured output schema in a API parameter itself. So I think the LLM creators are also like realizing what's important and adding into their APIs itself. So prompts are great, but I think we should not overload it with all the context.
Too much context can be equally bad as much as like not enough context.
I think RAG was the first, or like one of the first techniques that all the engineers worked upon, right? So I think everyone would be familiar on how we created like vector databases and indexed our documents and just hoping that it would work. And I think that's a great starting point. Everyone should do that. We also focused on how to enhance those by adding your freshness, because your data gets stale very quickly. So you need to update your vector indexes, and then also how to rank it properly, because only you have the knowledge on what is important. So you just can't say to this RAG system, just give me the top K items. You know how to rank it properly, so you should add that ranking logic itself.
No, that's such a great point. I think like even with ranking, right, I feel like it just seems so simple in theory, but how do you decide relevancy just based on like ranking? How do you even assign that? There are like so many interesting takes to that, and it can get complex just on its own. The other thing from like retrieval that I honestly really liked was also just like associating memory. LLMs are inherently stateless, which means that in order to like bring any kind of a personalization layer, we do need to think about the right level of user information that we can store. And that opens up like an entirely new can of worms, right? Like GDPR, CCPA, like how do we make sure like privacy is like factored into these while still maintaining the right state? So I think like retrieval, people just like kind of like zero down into RAG, but it's just such a huge complex space with like so many niche problems within that as well that we really need to like get on the same page about.
That's true, yeah. And there are like a whole new world of startups based on just adding memory to it.
I think this is the single most crucial thing that we need to build with, like as we build our AI native systems, because the reality is we are all learning what AI systems work like in prod, which means that it's really, really important to build the right guardrails to make sure we engage human at the right point, or even that we abstain when necessary, like and try to work against like LLMs behavior, which it typically prefers guessing over abstaining because they're trained to like be rewarded that way. And like kind of juxtaposing that like with like things like healthcare, for instance, or even like where a lot of teenagers and like young people are using AI in different ways, and there are more and more cases coming. Like so, just by making sure having that safety layer to make sure that the LLM does not provide any irresponsible answer that can lead to consequences on impressionable people, or like cases where it can lead to more harm, is like the single most important thing that I think we need to keep in mind.
Yeah, I think LLM observability is my favorite topic, and I can go on lengths and lengths talking about it, but I really love that diagram we had, which showed a loop of how to evolve, continuously evolve your AI system. You take your data set, you evolve your prompts and your retrievers, you see what works in the online world, you attach feedback, automated as well as human, and then you again improve it in the offline world. So I think this loop that we showed is like really critical. Two thoughts. One, AI is evolving and our patterns, our practices should evolve with that. RAG works now, but it may not work for your specific needs. For example, I know that Klein does not use RAG and they use something else called abstract syntax trees to work on it. So evolve your patterns. And two, integrate LLM observability from the start.
My closing take honestly is like about the engineering of it, like which I think is the crux of this talk overall. So as we build all these like new products, we're all like learning so many different things. So it's actually like a good time for us to start having conversations and start incorporating AI native engineering as a discipline on its own. And as we all talk and learn from each other, hopefully we end up at a point where we have enough like structure, just like we have observer patterns, factory patterns, even around these systems, and we're all able to like just usher in like a new engineering era on its own.
Thank you.
Thank you.